Good morning. Welcome back to day 2 of the PENC Raleigh seminar. I am Katie Cox, PENC Membership Director. Thank you all for joining us today. If you did not receive your PDH certificates from yesterday, please send me an email. They went out in 2 batches, one for the morning session and one for the afternoon session. So please check your email, make sure that you receive those. All right, our first presenters today. We have David Dawson, the Global General Manager, Industrial at DBM Vericon. David oversees the industrial design and industrial detailing divisions of DBM, sister company of Grey Wolf, bringing extensive experience in engineering, design, steel detailing, and digital engineering. David leads the division's strategic initiatives, business planning, and business development. David holds a bachelor's degree in law and a bachelor's degree in commerce and has over 20 years of commercial, corporate, contract, and business management experience. We also have on Isaac Hurd, Program Manager, Strategic Projects at DBM Global, and Chris Bailey, President at Grey Wolf Integrated Construction Company. Thank you all for being with us.
Okay, well, good morning, everybody. So my name is David Dawson, and I'm the Global General Manager of Industrial for DBM Vericon. As already introduced, we are a sister company to Grey Wolf. As many of you might have gathered from my accent, I'm based over in Perth in Western Australia, and with Western Australia being one of the greatest and largest mining centres in the world, with considerable mining activity ranging from the largest iron ore mines in the world to lithium, gold, copper, zinc, nickel, mineral sands, bauxite and uranium. So there's a considerable mining sector here, and in addition to that, there's a very active petroleum industry with some of the largest LNG projects in the world. So it is very much a very large sandpit in Western Australia. And today I'm here to talk to you about de-risking project delivery through integrating design, detailing, fabrication and construction activity. In particular, I want to talk about working collaboratively with other parties to achieve a better and less risky outcome to your project delivery. So the first thing I wanted to introduce you to is my backyard in Western Australia. So the picture you can see on the screen at the moment is in the far north of the Pilbara. Internationally, you might refer to this as the true outback. Internationally, you might also think about it as being where you'd imagine a very stereotypical Crocodile Dundee-esque style character wandering the landscape. But in all reality, it isn't all about picturesque vistas. It's a very, very remote, very hostile environment with extremely challenging building conditions and enormous risk exposure when things go wrong. The scene that I'm showing you on the screen at the moment is the location of many, many Australian mining projects in this Pilbara region. So jumping to the next slide here, it's giving you a bit more perspective with the little gold star there as to where we're talking about there in the middle of nowhere, really. And today I thought I'd talk through a bit of a case study on one project in particular that's associated with that region and present some of the risks that you would imagine that you would see working in that type of region as well. And hopefully through going through these examples, you'll see that some of the examples in the mining sector in Western Australia actually very much relate to what you'd experience back home as well. So this particular project, it's a very, very large 80 million tonne per annum iron ore crushing facility in the very, very remote northwest area of Western Australia. So at 80 million tonnes per annum, this makes it one of the largest iron ore mines in the world, with a total install cost of about $3.4 billion US. What makes this very interesting, in my opinion, is when I explain this to people internationally, is just how remote these types of mine sites are. The little blue line you see on the screen at the moment, that's about 850 miles from Perth. And Perth is really where the nearest mining, fabrication and major engineering hub actually is. To put that into perspective, I put a little map of the southeast corner of the US to scale on the screen at the moment. And apologies, my little line there is not particularly accurate, but it does give you a bit of an indication as to how far it is from Raleigh to Florida Keys, which is about 850 miles, and as the crow flies. And in this particular scenario, you can imagine driving between those two locations and not seeing a single large civilization in between. And that's very much what you experience in Western Australia. There is nothing in between. So the cost and risk associated with a project like this from a remoteness perspective is incredible. So it's very extreme weather conditions. It's desert at most times of the year with very, very harsh, strong and dry conditions. And then at other times there's cyclones and floods. because it's very remote. There's very, very high on-site costs. All workers are flown in and out, so there's no nearby settlements that these people are located in. So everybody has to fly in to mine and fly out again. And that's the same during the construction phase as well. As you can imagine, with those types of conditions, there's very extreme HS&E risk on site. And likewise, there's very limited capability and capacity of experienced senior resources to be able to deliver these types of projects. And this is an issue that's not just prevalent in Western Australia at the moment, but as a result of COVID and the pandemic conditions, we're seeing this issue globally now, where lots of industries are very, very affected by the ability to gain suitable people to do the work that's required. So from a financial perspective, you could look at this potential impact when we're constructing a project of this magnitude with all of those types of risks in mind, without even considering the actual delivery risk associated with the design process, as being worth about 220,000 tonnes per day, based on it being an 80 million tonne per annum facility. So the current iron ore rates, that sits at about $21 million a day for every day the project's late in terms of lost revenue opportunity. So whilst this is a very, very large mine, it does present fairly consistent types of scenarios to what we'd expect to see in most mining projects in Western Australia. And I think as we start to see some of these parameters popping up more and more across other sites globally as well, I'm sure there's many scenarios there that you can personally relate to as well. I'm going to do a bit of a gratuitous plug for our company, but it's providing a little bit of context as well to why I'm here talking about this particular topic. So what you see on the screen at the moment is DBM Vircon's relationship with DBM Global and its sister companies as well. So DBM Vircon is part of a group which work throughout the US as well as internationally. We work very closely with Grey Wolf, Schuff Steel, Banker Steel and Aiken, our sister companies, which are very US centric and very focused on the US market, and particularly in the steel construction and fabrication space. So our role at DBM Vircon is to provide specialist 3D modelling, detailing and digital engineering services, which fits hand in hand with the types of services that our sister companies offer as well. So in a lot of ways, we integrate with our day-to-day operations with how they work. So without jumping into too much detail of what you see on the screen at the moment, the context being, we've been around for about 55 years. We have offices in 8 countries, and we have a little over 850 resources at DBM Vircon. It's specialising in that 3D modelling and drafting space that's very, very closely linked with the steel fabrication industry. And likewise, just a very brief overview of our locations as well, which also provides a bit of context for the presentation as well. And so understanding that we are originally born and bred as DBM Vircon in the Australian market provides a bit of context for why we have such an interest in the mining sector, and likewise what that's actually caused us to do. So if you think about how remote these sites are, they're very, very large scale projects. There's strong market constraints on how we deliver the projects. And the fact that these issues have been around for a very, very long time, they're not new issues, but they've been there for decades as these mines have been produced. It's caused and catalyzed a change to how we operate as a business. And it's pushed a very, very strong focus on getting things right before they get to site. And so with that in mind, it's catalyzed that change towards moving towards 3D technology very early. And so DBM Vircon's teams of pretty early adopters of 3D technology back around nearly 30 years ago, and very heavily focused on using that 3D modeling technique into the mining sector in a somewhat collaborative environment. And that collaboration environment has changed over time. It's not something that's been consistent from start to finish. It's a continual evolution of how we engage between shop detailing teams, engineers, and all parts that flow on either before or after that part of the process too. Starting at a very, very high level, what is integrated design and detailing processes? And I apologise for any of you that might see this as being very obvious, but looking at a very traditional level, what a traditional delivery process looks like between an engineering phase of a construction project in the mining sector, or a commercial sector for that matter, from engineering through to shop detailing and shop fabrication, and then obviously construction flowing on from there. One thing you'll notice about this traditional delivery model is that it's very segmented. Now, I appreciate that most projects that are traditional in nature these days don't exactly operate like what I'm showing on the screen. This is giving you more of an extreme example, but the point is each stage of the delivery process is very separate. We start and finish each stage. We leave the liabilities with the parties as we transition from one to the next, and then we move on. And so I should also point out as well that there's nothing wrong with this. This is a good, solid delivery model, and it certainly has its place under certain circumstances and has been an effective way of delivering projects for a very long time. So I'm certainly not advocating that it doesn't have its place. What I'm suggesting is that sometimes there are alternative delivery models that are more effective for the circumstances. So talking through what an integrated design and detailing delivery process actually looks like, at a very, very high level, what we're looking at is working alongside design engineers, not separately to expedite that detailing process. And as an outcome of working collaboratively through that, trying to produce a better overall design that's going to produce a more efficient delivery to the project. So at a very, very high level, the detailing team will act as an integrated modeling team that works side by side with the engineering team. And so rather than it being a very separate fabrication deliverable process like you're seeing at the moment, we bring that forward. So the 3D modeling process works side by side and concurrently with the engineers. The intention of doing this type of delivery approach is that rather than having two separate modeling processes, we have one single integrated approach where we produce a single pass fabrication ready model as part of the engineering process rather than after the engineering process has been completed. And so this means that by the time we finish the engineering process, we're in essence ready to move through to produce 2D fabrication deliverables. The outcome of being able to do that is rather than the fabrication process being pushed out further into the future, it allows us to identify some of the issues that need to be resolved during the fabrication and construction period, utilizing people that are typically working in that time period, so the detailing teams, and utilize their skills and experience to help inform the engineering teams earlier in the process as to how we can identify and remove some of those hindrances. And ultimately, the outcome of that is that we're able to push forward and will bring forward the fabrication process as part of that process as well. So as you can imagine, there is a considerable benefit from a project de-risking perspective as a result of being able to identify some of those processes and problems much earlier. I thought I'd try to avoid going into too much detail as to what one of these workflows look like, but I also kind of figure that if I'm showing you a pretty diagram with 3 lines on the screen, it doesn't give a lot of credibility to what I'm talking about. And so what I'm actually showing on the screen at the moment is a summarized version, and I've got a few slides to follow this as well, that show at a very basic level what that integration looks like between the engineering teams and an effective shop detailing team and being able to integrate for a collaborative detailing process and design process. I should also point out as well that this isn't a one-size-fits-all. What I'm showing you at the moment is based on the case study that we're talking through as well and how this particular project was delivered. But I can also tell you that in our experience in working in this space, there's no two projects are the same. You can't use a cookie cutter approach. There's no one size fits all. It's a matter of identifying the right type of process and workflows that are going to suit the parties that you're working with. You'll also note as well with what you can see there with some of the lines to the left where we're looking at the 30, 60, 90% design gates. You'll also see that the detailing gates in green in the middle, they don't really fit perfectly within the engineering gates. They are somewhat different. And one thing that's very important is that we recognize that and we communicate those differences so that we don't end up in a situation where miscommunications end up with additional work for parties. So the condensed version you can see here, I'm just going to split it out in a few seconds, but you'll see there are 3 key stages from a shop detailing perspective, which I will focus on for this presentation, figuring that most of you are engineers, you'll certainly understand your engineering processes. And what I'm trying to describe to you is how the detailing process can slide in side by side with that. But we'd look at 3 main areas of that delivery process. First one being a 3D process with design assist. This is a very early stage of engagement, and you can see that we're looking at that being between the 30% design to some point between 60 and 90%. And then we transition to this other stage referred to as the shop detailing modeling stage. So it's still a 3D modeling stage, and it finishes up at around the 90% design mark. And then we transition to a 2D phase after that point in time. Jumping through to a more detailed look at what that design assist phase looks like, without going through every dot that you can see on the screen there, what you can see is that certain activities happen in certain orders. And as you can imagine, with any engineering workflow, there's a requirement to ensure that there is a process and procedure for when certain activities are undertaken. From a shop detailing perspective, what I would typically encourage is that we reach a certain level of design completion before we commence doing any detailing work whatsoever. And we have had experiences where our detailers have been engaged much earlier and sort of engaged from, for argument's sake, 10%, 15% design, so to speak, very, very early in concept. And as a result of that, they tend to, being detailers, get more detailed than where the design's actually up to. So it's important that we reach a certain stage of engineering development before we actually progress to this stage of delivery. But in essence, what I would advocate, and I'll use structural steel as a good example, the point in time that the detailers are ready to commence work is that point where the engineers feel comfortable that they are in a position where a wireframe model could be produced with steel sized and locations all being correct. From an industrial perspective, things like grating and handrail are indicated in terms of extent in the model. And there are design details that are able to indicate where standard and non-standard connections could be applied. So connections at this stage, to the extent that they are available, could be provided on simple sketches. The intention at this point in time, though, is not to have a complete set of design available, but to the point of being able to produce a detailed model wireframe, a geometrically accurate model, the information must be available and present to allow that to commence. We have had situations previously where we've worked through and the engineering hasn't been fully locked down to that level of completion and has resulted in considerable amounts of rework, which would obviously not advocate as being a good approach for delivering a project. But I'll cover off in a little bit more detail at the end just around that communication piece as well. In any case, in this design assist phase, what we need to accept is that the design is somewhat fluid. So the detailer that's being engaged is not being engaged in a level of completeness and a rigid approach that you would typically expect in a shop detailing and fabrication environment, but rather there's an expectation that the design is going to change, that the model is going to move and evolve as we go. So the shop detailers, whilst producing this model, they expect that to change. They are also going to be able to produce it in a way where, at least to the extent that things don't change, they are ready to progress to the next stage of delivery. So it's done in a way where it's shop detailing ready. And that's the whole point of this process, that it's building up upon that through one stage to the next. Another thing that's really important about this stage of the project as well is that there is a high degree of communication between the engineers and the shop detailing teams that are involved. In the scenario that I've been talking through as well, it's somewhat of an integrated fashion where the shop detailers sit side by side with the engineers, and we've done that face to face, and we've also done that separately, particularly in pandemic times, quite remotely as well, and it's worked quite effectively from a remote standpoint. As we transition from that 30% design mark and we continue to undertake design reviews, and we transition to a point in time where there is additional engineering information available. So connections are further developed. There is additional information available around the erection locations. They've been finalised in terms of what's going to be done in the yard, off-site. Likewise, any additional information about non-standard connections, and any additional information around stiffeners, handrail, grading, chutes, platework furniture, liners, etc. Once that information continues to develop, the detailing teams that are working side by side with the engineers will continue to incorporate that level of detail as they go. Again, these workflows are really, really contingent on having clear and easily understood by all parties information and gates that prevent the detailers or the engineers misunderstanding where each of the other parties are up to. So it's really, really important that both sides fully understand where the engineering is completed to avoid any additional rework and confusion. And that's one of the common issues that we often see coming up. So the intention being at this point in the project to get the model to a point where at that 90% engineering review mark, the model is complete. And so the shop detailing model can then be run from that point in time to produce shop detailing deliverables without virtually any further adjustment or modification. One thing that you'll see at that point in time as well is that at the completion of the model, there's a very, very clear and concise MTO that's available for all parties on the project. Now, as you can imagine from a risk perspective, when parties are, especially with changing steel prices and material prices, it's pretty important to have a clear understanding of what your project costs are going to be. And this means that it's not just at an engineering level of accuracy, but rather that it's a shop detailing level of accuracy at 90% design. So very, very accurate and useful information is being produced at that point, rather than later down post-procurement process where things are getting further refined. So it's a pretty important step, I think, that we note in the Australian market as being really important for off-site projects as well. I won't go through the 2D detailing process in a great deal of detail, but as you can imagine, if we're getting to a point where we've worked collaboratively with the engineers throughout the project delivery cycle, we're going to get to a point where when we're starting to run drawings, when the majority of the issues that would historically have come up later in the project, where a shop detailer is querying and clarifying information that may not have been fully considered from a fabrication and erection perspective, that information is already incorporated into the model prior to 90%, because it's been reviewed in a collaborative environment with the engineers. So in theory, what we've actually been able to achieve is virtually no changes that are happening post 90% design. It goes without saying that we then transition through to a fabrication stage of delivery, and then construction. And there's a few other activities at the back end there around ads building, which I won't waste any time going through today. But as you can imagine, the nature of this engagement being concurrently with engineering, it's going to be a lot more involved and a lot more collaborative, and we're going to identify a lot of things earlier in the process than what you would typically bring up. Looking at this from a practical perspective, going back to our original case study, and I'll jump into a few more details there about that case study, but it's that project was a large 80 million tonne per annum facility. At the point in time that we were engaged on that project, it was running considerably behind schedule, close to 12 months in total behind where it was originally supposed to be up to, and it was still in earlier stages of design. Approximately half the project was sliced off, and about 11,500 tonnes worth of steelwork in that stage, which what could be referred to as the inflow circuit for the project, which consisted of 2 large primary crushing facilities, about 14 miles of conveying, and that ended up in a very large dual stacking conveyor over the top of the initial coarse ore stockpile. Whilst for some of you that might mean something and others it won't, the point is it was a pretty considerable package of engineering scope, inclusive of approximately 600 modules that were being produced for that stage of the project. In the initial stage of the project, the reason why we engaged in an integrated fashion with the engineers is because there was a late commencement of engineering. The project itself was late, so not just the commencement of this particular portion that was sliced off, but it was sliced off from another engineering company and handed over to company B. And at that point in time, there was fairly limited experienced designers available in the market. So the market was very, very busy. For that engineering company to identify suitable people and bring them in on contract to be able to deliver the project was going to be considerably more difficult than being able to identify a company like ourselves, which had a ready-made permanent staff with experienced detailing resources that was available to commence very quickly on the project. So the project commenced with a very collaborative delivery approach. We worked through the workflow requirements, which were very similar to what you saw on the screen there, with a few more details and obviously written details of how that all fits together. So a nice, clear written workflow. And then we started to engage in a side-by-side approach with the engineers. So our lead modelers were co-located with the engineering team, and those lead modelers stayed with the engineering office until approximately 60% design, where their modeling process then transitioned from them being directly on the tools doing the modeling to then transitioning the model to a broader team that sat outside of the engineer's office within our own offices. So that lead modeler role that we had then transitioned into more of a lead coordinator role, and they were responsible for coordinating design information with the engineers and then transitioning that information to other people within our team. This approach also further enabled DBM Vircon's offshore teams to be blended in with our onshore teams that were located with the engineers, which provides considerable cost benefit, as you can imagine, to the project. But without that getting to a point where that communication barrier was pushed into play, because we had team members that were located directly in the engineer's office to help transition that information between our internal teams. And likewise, those internal teams, as you can imagine, were working in one software, one environment, one set of models, and those models were live and consistent between the team sitting in the engineer's office and the team sitting in the offshore teams as well. So this provided very good levels of control over the transfer of design information and provided a much greater degree of efficiency with controlling that transition as well. So as you can imagine, this also provides a very fast-track delivery approach. And in fact, it got to the point where we regained about 12 months worth of delivery time relative to the other party working through. We, in essence, caught up with them and overtook them in terms of our ability to deliver that work, which is a fantastic achievement for the teams, because it was much more efficient to transition that knowledge and design information. Likewise, those models were also used not just by the structural mechanical teams working in collaboration, but the models were also fully federated back into an overall environment where the engineering teams were reviewing it across multiple disciplines as well. And this was done very, very regularly. That information was run using overnight routines to pull all that information back in so that all parties had direct access to that detail as we went. One of the other interesting outcomes that comes from a project like this as well is that we can actually, rather than produce engineering design drawings for sign-off and reviews, those can actually, so because we've got a detailed and highly accurate model that's being produced as we develop out across the delivery cycle of the project, at the points in time that this information was required, it was possible to extract views of that information from the shop detailing model. So it eased the need for separate deliverables to be produced because they were produced directly from that same environment. And as the engineers had used the shop detailing model throughout the delivery cycle to review their own work at the various engineering gates, it ensured that there was a degree of transparency and control that they had directly over the modeling process as well. At the point in time that we transitioned out of the design stage of the project at that 90% mark, it was very much a separate engineering and detailing process again, as you would have under a traditional delivery model. And at that point, we started to raise more traditional RFIs for ensuring that design information and changes were tracked, because the engineers were no longer reviewing and signing off on day-to-day changes within that model. So the benefit being there were very few of those at the very back end, because everything had been resolved up until that 90% design mark. And at a very high level, just looking at the quantum of deliverables that were produced on a project of this size, just to give you an idea, there's approximately 80,000 shop detailing drawings and 116,000 fitting drawings that were issued just for this portion of the work. In addition to this, because of the nature of the mining sector and this particular client, there were literally millions of highly accurate metadata attributes that were issued across each of these modules and all of the fittings that sit within them. The modules that were produced, as I mentioned, I think before, approximately 600 of them, and they were fully fitted out and weighed up to 350 tons. To give you a bit of an idea of size and scale of some of those, there's a picture of one of the surge bins that came off the primary crushing unit, and a few other bits of fruit that sit alongside that as well on the trucks behind it. This is not an unusual sight to see in Western Australia, to see modules of this size being transported by road. These particular modules were actually not fabricated in Western Australia, but rather they were fabricated in China. And they were then shipped to a port that's approximately 200 miles from this mine site and then carried on road. However, there were other modules that were produced, such as the ones on the screen there at the moment, that were produced down in Perth and then trucked to site as well. But obviously, different road conditions and parameters result in different size modules being able to be transported as well. But it's certainly a pretty amazing sight to see those running down the road, that's for sure. So I thought I'd cover off a few pros and cons of this approach, which provides a bit more context to that risk element of why or why not would you go down this pathway to try and control your project delivery. And some of these things you'll find have a little bit more of a flavour that is applicable to your own market as well. But looking at more of a traditional approach that we started off with, there are, as I mentioned before, pros and cons of this approach. And some of the pros being, depending on the nature of the project, it can actually be more cost effective and more efficient to allow the fabricator to engage at that back end once the engineering is fully complete, because it allows the engineer and the owner and all other parties prior to be able to pass on a degree of risk to the fabricator to manage that part of the process. So if we're wanting to try and keep those lines very separate so that the engineer is able to step away from that element of risk, then this might be a more efficient model. It also allows the fabricator, who presumably in most fabricators, it certainly is the case with Grey Wolf and our sister companies, but to manage the process to best suit their delivery processes. So there is an element there where if the detailing is done quite separately to the fabrication process and construction process, depending on the nature of that detailer and their relationship with the potential fabrication companies that are going to be involved in the project, if they haven't considered the right things during the process, then it's going to make it much more difficult for that fabricator to deliver the project. So by contrast, if they're able to engage directly, the fabricator engage the detailer, it can result in them picking a detailer that's fit for purpose for what their needs are and allows them to manage the detailing priorities to suit their fabrication priorities as well. Now, the downside of that, and we see this a lot over here, is that some fabricators may opt to utilize the cheapest shop detailer that they can, because it might suit their purposes, but it might not take into consideration what the end user or the engineer or other parties involved in the projects actually might need or want from the modeling process and the detailing process as well. So you sort of lose a level of control, which may or may not be a problem depending on the project. Likewise, as I covered off earlier, the way that this process will work is that there's going to be a lot of queries that come in at the back end. So because the shop detailer hasn't been involved and integrated into the engineering process, the fabricator is going to, and their detailer are going to pick up on fabrication, constructability, and erectability issues that aren't usually considered until the detailed modeling is actually completed and some of these issues become more prevalent and available to be viewed. The obvious thing that happens when we start to get to this point is that you're going to find it very difficult to manage the control of that information transitioning between the detailer through to the fabricator, through to an engineer, back to the fabricator, back to the detailer, let alone if there's general contracting companies involved or other parties involved in this process. And so this means that we end up in a situation where there's long chains of communication that need to be controlled, and it can cause lengthy delays to the project. And not only just through that information transfer, but also through rework that's unanticipated as well. So there is that certainly to be considered. Likewise as well, if we look at a very traditional approach where it's very segmented and waiting for the engineering to be complete, it does also prevent certain aspects of detailing and subsequently fabrication to be commenced earlier. So there is obviously an advantage there if that can be done effectively. And looking at this from more of a optimized approach, so looking at the workflows that we've been looking through, as you see on the screen at the moment, these are some of the advantages as I see it that are beneficial and available when we look at a more collaborative delivery approach. So as I mentioned at the beginning of the presentation around the availability of resources to be able to undertake design functions on projects, if they're in short supply in a particular market, it allows, through using this approach, to utilize people that are experienced in modeling to be able to be engaged by the engineer to help assist that detailed modeling process much earlier and more effectively without having to go out to 15 different contractors to get that work done. So one company can come in and work collaboratively with another. Likewise as well, you do have that ability to engage with an experienced detailer that is familiar with delivering on large projects, might be familiar with some of the parameters that are relevant to that individual project, such as modularization or, for argument's sake, working in a more multidisciplinary environment. That's not just around considering structural steelwork. And this means that the engineer is hopefully going to get more meaningful input from the resources that are engaged, that have a good understanding of fabrication, constructability, and erectability. Inevitably, this approach, if it's done effectively, will result in schedule compression, which is going to allow us to take a bit of risk out of the project. And it'll also allow us to release a lot of long lead items a bit earlier from engineering if that process is managed effectively as well. Goes without saying that there's going to be a minimisation of any duplication of modelling efforts between the parties. And as I mentioned before as well, there's also the added benefit of being able to produce 2D engineering deliverables if they're required as an output of that 3D model as well. So there's a further reduction in efforts. And likewise, as we briefly touched on before, we do actually have that benefit of being able to produce earlier, highly accurate MTO information for procurement, which is going to be able to de-risk some aspects of the later stages of project delivery as well. One of the things that isn't often considered as well is just around being able to use that model as a single source of truth. Now, in a traditional environment where we transition from one model to the next between engineering and detailing, we do lose an element of that information and history as we transition. And by utilizing one model throughout that process, we eliminate that transitionary nature of the models, and we end up with one model that is that single source of truth. This also gives the engineer a high degree of control over the final deliverable requirements. So back to where we were talking about the metadata requirements in the previous slide, this now enables the engineer to have some control that they wouldn't otherwise have over ensuring that things meet the standards that are required for the client on the project as well. So I guess this would, I suppose, lead many people to ask, well, why would this be beneficial to an engineer? Because ultimately what I'm suggesting here is that you engage a detailer to undertake some of the aspects of project delivery that would otherwise have been undertaken by your own internal modelling teams. Now, I can certainly see that there is an initial potential financial disadvantage to the engineer out of what I'm advocating here. However, in the long term, this presents considerable benefits to the engineer. And being able to use a detailer to boost their capacity without taking on board market risks associated with resourcing challenges that are in a particular market. So you can gain experienced resources immediately into your team that are familiar with working together. And often if you're engaging with the right detailing company, they've got experience working in that fashion as well. That can work really effectively without having that time to go through a learning curve of onboarding these people into your organization. In theory, out of delivering to these delivery workflows, you should be able to deliver a more efficient delivery workflow, which will better meet your client's needs and provide improved performance and reputation with that client as well as looking for more innovative and collaborative ways of delivering. The other benefit that often engineering teams don't often consider, because we often look at from a detailing standpoint as a great opportunity when we work with engineering teams to gain a better understanding of how that engineering team works and some of the engineering considerations that go into delivery. But on the flip side though, there's also a great opportunity for the engineering teams to gain some knowledge from the detailing teams as well, where they impart knowledge around fabrication, constructability and erectability that are things that are often not fully understood due to the life cycle of a project by the engineers. So it's a really good opportunity to learn from each other. We're just finishing off a project at the moment for a lithium concentrate facility in Brazil, where we've had very consistent feedback there from our team saying how much they've learned from the engineers, and by contrast the engineers are giving exactly the same feedback back the other direction as well. So it's great to see that sitting there in that collaborative environment has allowed the parties to communicate more effectively to provide a truly improved project outcome. I thought I'd provide a couple of do and don't points, do's and don'ts, if you will, about some of the things that I've seen work effectively and not effectively. And it's a little bit all over the place. I apologize with how I've constructed these, but it does give you some ideas as to some things to consider as well. So whilst I advocate that this is a great idea, designing and detailing teams working hand in hand together, they do have two very separate roles in the process. And so from a detailer's perspective, in my opinion, it's not a good idea to get them involved too early. From what we've seen to be most effective, at around that 30% design complete mark, where concepts all locked down and some of those attributes that I was talking about in the earlier slides have been established, it means that the detailer will get a reasonably clean run at getting things moving. Detailers generally, by virtue of what they actually are, detail-orientated people, will go down rabbit holes if they're engaged too early at that concept stage, and you will probably waste hours that could be otherwise be avoided. So part of the way that you control that is through that very, very clear communication at the front end, having workshops between both parties, sitting down, working out very, very clear workflows. Example being something like what I was talking through before, but having clear and written documentation that's fully understood by both parties involved as to when certain parties will be doing certain things. So you don't end up in a situation where one party assumes that one's waiting for the other one and the other one has gone full steam ahead and modeled and detailed out something far beyond where the engineer, for example, thinks things are up to. So very, very clear, defined activity gates, establishing a clear standard of what the deliverables will be required for the project, ensuring that metadata requirements and expectations are locked down and very, very clear by all parties at the beginning. Point on the side there as well, just ensuring that we don't over specify model metadata requirements during the fabrication stage of a project, because it does result in some level of inefficiency in deliverable production. And so some of those things, it's better to actually apply them after the fact as a post-IFF application. And finally, as well, to ensure that you've got very, very clear review gates. So we don't want to keep polishing things continuously, but rather to have defined gates and points in time where things are officially reviewed by both parties together and changes are somewhat documented so that there's a clear understanding of what needs to happen as well. The final point that I've got down the bottom there is also a very, very important one as well in terms of ensuring software interoperability is fully considered. And this is something that often isn't done very effectively, where people assume that what they've done previously, working in isolation, will work from start to finish of the project, but rather they should look at how they're going to integrate together, how they're going to receive information backwards and forwards, and trial that at the very, very beginning of the project with test deliverables to ensure that it's working effectively. And that allows you to iron out some of the problems that will otherwise come up when you're in the heat of the project and it becomes quite problematic. So these are a few of the points that I thought were relevant. There were certainly points that came out of the outcomes of the large project that we were talking through before. And a lot of these issues that we're talking through, we're now starting to see them applied into a lot of our projects globally as well. So it's not just the Australian mining sector, but we're seeing a lot of projects popping up in for argument's sake, Stadia, and also looking at other more infrastructure orientated projects as well, where we're continuing to work in increasingly more collaborative environments, driven by some of the project risk factors that we discussed throughout this presentation. I'm going to hand it over for questions now. I'm mindful I've been speaking for 45 minutes and I think we're allowing for 15 minutes of question time. So timing should be perfect from that perspective.
All right, that's great. Thanks so much, David. We do have a couple of questions. The first one, do you find it is difficult to include outside engineers / fabricators in an integrated delivery if they are not familiar with this strategy?
Good question. We've had mixed experiences is probably the best answer to that. I had a very interesting experience a couple of years ago on a large lithium project where we were working with 5 different engineering companies, one owner that was our main contact, but 5 different engineering companies working in a somewhat collaborative environment between each of the 5 concurrently. And the experience that we had is some of them adopted and adapted to that environment really, really effectively. And a lot of the time it was because we sat down and had very clear rules of engagement between us. Others didn't want to embrace the strategy. And when I say others, it was, say one party would not particularly embrace it. Others over-embraced it in the sense that they tried to cut down on the level of information they provided too far. So it was certainly across 5 different companies, we saw very different levels of capability in being able to adapt and evolve to that approach. And I think probably one thing that we didn't do as effectively as we could have is probably sit down with each of them and identify their own unique circumstances and how we're going to make that work effectively. So we just assumed it was more of a, well, we've established this with the owner, this is how it's going to work. And so we worked with the primary engineering company and we got a nice workflow working with them and assumed that the other parties would all flow through to the same sort of style approach. What we didn't consider is that they had different levels of sophistication with their 3D modeling in-house and technology usage, different software requirements that they were using, and they came from slightly different origins and backgrounds as well, and had different types of workforces, some more full-time, some more contractors. So yes, I can certainly see there are difficulties. My recommendation advice is to engage early, sit down, work through the details, and make sure that each of the parties is very comfortable with what they're going to be doing on the project.
Okay, great. Our next question, you mentioned working with two groups, with one being a coordinator who wouldn't do the day-to-day design changes during engineering. Not sure what James, if you want to clarify your question.
If you could, James, it might help me to answer it. Assuming James isn't going to provide any clarity on that, what I might just do is assume that what he's referring to is my comment about my case study example, where the lead modelers who were working from within the engineering company, so they're working side by side with the engineers, they transitioned from being on a role where they were producing all the upfront detailed model. When it got to the point where all of the finer details were getting added in the back end, so all of the standard connections, and once some of the non-standard connections have been fully developed out, once it got to that point of the project and the application of design information was becoming a little bit more simplified rather than being more of a design assist style role, the lead modeler transitioned from being more of an on-the-tools lead modeler to being more of a coordinator of information. So because they'd been involved in the design process, they had the history of the design and how it had evolved and all of the information that sat within it, they were able to really effectively communicate not just with our teams externally, who were doing the modeling from there on out and then subsequently the shop detailing, but they were also able to work very effectively with the engineering team in ensuring that any changes to that design information were effectively understood and communicated through. I hope that answers the question.
Okay, yeah, I got, let's see. When it came to facing customer, how was the support for the coordinator arranged and what was the best practice used so the information for needed changes or customer comments were properly passed to the group during the changes? Was it purely RFIs? And did you have a collaborative tool that kept things up to date?
So on a lot of the projects that we are involved in these days, we use Trimble Connect as a good means of communication. So being shop detailers, a significant portion of our work is undertaken in Tekla, so a Trimble product, which integrates really, really well with Trimble Connect. But depending on the project environment, we use a myriad of other tools to track and control that change of information. But it really depends on the stage of design development that we're engaged at and where we're up to at that point as to how tightly it's controlled. At earlier stages, where it's very much an extension of the engineering team, we typically use the degree of control that that engineering team has in-house to control that change, because ultimately they're going to be reviewing that model at their various engineering gates, and they are going to take a degree of accountability for ensuring that they fully understand where that engineering model is up to at that point, because it's still an engineering model at that stage, not a detailing controlled deliverable. As we transition out of that engineering world and the design reviews have stopped and the engineers are no longer taking accountability for those changes, that's when we traditionally move to a more traditional model of having stock standard formalized RFIs, which are either as formal documents or still tracked within the model, but with clear closeout of those items as we go.
Could you confirm, is the tool called Trimble Connect?
Trimble Connect. So Trimble is the software company, very closely affiliated with Tekla. Well, it is the owner of Tekla.
Okay, great. Next question. What were the main challenges during the pandemic that affected the overall process of the delivery of the projects?
Very good question. I can certainly refer to, outside of the examples I've used here, we had a very large stadium project in Sydney that we were undertaking from Perth, and also using our offshore teams as well, where we had fully intended on co-locating a team within the engineer's office. And for obvious reasons, that was very difficult to achieve. And it got to the point where it was near on impossible for us to actually get our resources over to Sydney to be able to sit in the engineer's office to make that work. And so that was certainly challenging, but we were very lucky that as an organisation, we are very much set up in a way where our offices are interconnected, and we're able to work very effectively remotely. So our models are live regardless of whether I'm sitting in the office right now or sitting at home or sitting in Manila or sitting in Perth or sitting in the US. It's the same consistent model environment. So that certainly was a huge advantage to us. But the downside being the relationship piece that we were talking about there at the beginning, and the importance of actually having close and clear communication with the engineers and other parties for that matter in the process, it becomes much more strained. So if you've got a long-standing relationship with engineers, fabricators, you're used to working with those parties, you can certainly rely on that. But when it's new parties that you haven't worked with before, it's certainly very challenging to build rapport and to build relationships that help you to effectively deliver these types of projects too. Fortunately, we were successful in being able to deliver that job, and it went up on time and quite effectively, to be honest. But I can certainly say that it was put a fair bit of strain and pressure on the team.
All right. Thank you so much, David. I think that's all of the questions that we have for today. We appreciate your time and thanks so much for being with us.
Most welcome. Thank you.
All right, everyone on the line, we have a short break. Our next session will start at 9:45. You have a new link for that session. If you have any questions, please reach out to me via email. All right, David, have a great day.
Thank you.